This is lesson 10.3, Generating Equivalent Expressions. Our essential question is, how can you identify and write equivalent expressions? Now this lesson is kind of long, so I'm going to break it up into several different parts. The first part is learning about the properties of operations, and what I have here, I'm going to zoom out so you guys can see. I've made a little foldable that I want you guys to make and tape into your notes. So if you look at this foldable, I basically just got a plain piece of white construction paper, and so this is a plain piece of construction paper. I just used about half of it, and then I folded it in half. Once I folded it in half, I cut little strips to make tabs for each of the words that I need. So I'm going to go through them with you guys real quick. We're not going to spend a whole lot of time on most of these today. The one we're going to focus on in this lesson is the one right here that has the star with it, the distributive property. But we're going to use the other ones in the next lesson. So click pause if you need to so you can make that foldable. It does need to be taped into your notes. The first tab says commutative property of addition, and the example for that is 3 plus 4 equals 4 plus 3. So basically what this property is saying is we can switch these. It doesn't have to be in a certain order with addition, because they can switch. 3 plus 4 is 7 and 4 plus 3 is 7. So it doesn't matter which one comes first. The second one is the commutative property of multiplication. Same kind of thing as addition, but with multiplication. So if we do 2 times 4, we can flip it and say 4 times 2, and they both mean the same thing. They're equivalent. 2 times 4 is 8, and 4 times 2 is 8. So that works with addition and multiplication, but it does not work with subtraction or division. Next one is associative property of addition. So basically what that says is if we have 3 numbers, and we have these two grouped together, we can actually move that grouping and it still won't change the problem because it's addition. Because we know here 3 plus 4 is 7, and 7 and 5 is 12. We also have over here, if we did the 4 plus 5 first, we'd get 9, and 9 plus 3 is 12. So it means the same thing despite where the grouping symbol is. The same thing works for multiplication. So we have the associative property of multiplication. So in this one, it's the same kind of problem. We've got our grouping symbols here. We can move those grouping symbols and it won't change the problem. If I were to solve this, I would start with 4 times 2 is 8, 8 times 3 is 24. Over here, I would start with 4 times 3 is 12, 12 times 2 is 24. So they both mean the same thing. The next one, and the focus of this video, is going to be on this distributive property. The example here, pardon me, it's getting all tangled up, for the distributive property shows when we have a number on the outside of parentheses and 2 numbers on the inside, we can distribute or multiply that number on the outside to each term on the inside. So I would do 6 times 2, which I have here, and then 6 times 4, which I have there. Our last two properties are the identity properties. The first one is the identity property of addition. And you know, identity kind of means ourself, right? How we identify ourselves. And what that means is you can add 0 to any addition problem and it won't change it. It'll still be itself. So 9 plus 0 equals 9. That's the identity property of addition. The identity property of multiplication is where if we multiply any number by 1, it won't change. So we end up with this example here, 1 times 7 is 7. So with identity property of multiplication, you're multiplying by 1. With identity property of addition, you're adding 0. So again, part of this lesson is to have this foldable done, and you're going to show your teacher this as part of your notes. Okay, so the main part of this lesson is understanding the distributive property. And I labeled this with an A because this lesson is going to have several different pieces, and this is the part that I want you guys to start at. So your examples are going to say distribute, and you'll notice here that we have variables inside and not just numbers. So basically, if you were to have a problem like this, 5 times x plus 7, what you want to do is you want to distribute that 5 to every term that's inside the parentheses. So what this really means is 5 times x plus 5 times 7. Because I'm multiplying the 5 times the x and then the 5 times the 7. 5 times x just gives me 5x. 5 times 7 gives me 35. And this is as far as I can go with this answer. Okay, so all your problems are going to kind of look like this. So let's try one that's very similar to the one we just did. We have a 3 on the outside of the parentheses. And I know you might be thinking, well, I should do m minus 4 first, but I actually can't combine those because one has a variable and one is a number. So all I can do here is distribute, which means multiply. So if I rewrite this, that's the same as 3 times m minus 3 times 4. Well, 3 times m is just 3m minus 12. And that's where I would stop there. So hopefully you're getting the hang of it. We've got 2 more that are very similar to those 2. If you'd like, you can click pause, try them, and then click play and see if you get it right. On this first one, I'm going to distribute, and I always use my arrows to remind myself to make sure to multiply by everything inside the parentheses. So this becomes 2 times y plus 2 times 3, which equals 2y plus 6. And I'm going to stop there. On this one over here, this one's a little bit different because there's a number here in front of the letter. So this is 6 times 3k. And so 6 times 3k, what I'm actually going to do is multiply those two numbers. Well, let me write it out first. That means 6 times 3k minus 6 times 4. And then when I multiply those two, I actually get 18k minus 24 because you can multiply the coefficients there. And getting into a little bit of harder problems here, we've got some more letters, we've got different things going on. Let me zoom out so you can see all of them. All right, on this first one, even though typically in all the ones above there was only 2 things to distribute, in this one we have 3. So it wouldn't matter really how many are on the inside, we're still going to distribute that 3 to every single thing. So this means 3 times 2x plus 3 times 3y plus, oops, I'm sorry, that's a minus because there was a minus there, minus 3 times 4z. And I draw my z's like that so you guys don't accidentally think that they're 2's. So 3 times 2x gives me 6x. 3 times 3y gives me 9y, and then 3 times 4z gives me 12z. And that's my final answer. All right, looking at this one, I have 3x plus 4 parentheses 5 minus y. And here's where things can get confusing because some people try to distribute this whole thing. But you have to ask yourself, what is hooked on to the parentheses? And if I look closely, I'm just distributing the 4. I'm not doing anything with the 3x. So since I'm not doing anything with the 3x, I'm just going to bring that down. And then I have 4 times 5 minus 4 times y. So then when I work that out, I've got 3x plus 20 minus 4y. 2 more examples. Hopefully you guys can definitely click pause, try these on your own, and then click play, see if you got it right. On this one, remember, I'm not doing anything with the 7, so I'm just going to bring that down. I am distributing the 2 because it's hooked onto the parentheses. So that's going to be 2 times x plus 2 times 1, which gives me 7 plus 2x plus 2. Now, if you left the answer like this, I would say it was right, but hopefully some of you noticed that I have a 7 here and a 2 here. And then your next lesson, you're going to be learning how to combine like terms. And those terms are alike, so I can actually write the final answer like this, 9 plus 2x, because the 7 plus the 2 gives me 9. But if you wrote your answer like this, I would still count it as right for right now. And our final problem here, we're going to distribute 3 times. That's going to become 7 times 8x plus 7 times 2p minus 7 times y. When I work that out, I'm going to get 56x plus 14p minus 7y. And that is my final answer. All right, guys, good luck.